Okay, thank you everyone. My name is Chen Yue. I'm from Sichuan University, Chengdu, China. And now I'm going to introduce our paper, the Lasso, the large language model-based zero simulator for cross-domain recommendation. And I will introduce 5 sections. And first is the background of our paper. And the recently emerging field of the cross-domain recommendation, aka CDR, elevated the cold start problem. And CDR involves recommending items from one domain, that is target domain, to user based on their preference and historical interaction in source domain. For example, in Figure 1, by leveraging a user history of engaging with science fiction and superhero books, CDR can inform his movie preference and recommend the Iron Man. An existing CDR method focuses on training a mapping function that transfers user preference from the source domain to a target domain, utilizing the historical interaction of overlapping user present in both domains. However, this method often suffers from low data efficiency, as they require a substantial number of overlapping users for training, and in real-world setting, the overlap is often impractical. For example, on platforms like Amazon, only about 5% of users are overlap users. So to overcome this challenge, we introduced Lasso, a lower framework that leverage large language model as Euro simulator to address the cross-domain recommendation. Inspired by the remarkable ability of large language model to interpret user preference from limited data, Lasso enhanced data efficiency by reducing the reliance for extensive overlapping user. Specifically, Lasso employs the cross-domain training paradigm to fine-tune a large language model as a user simulator, enabling it to estimate target domain user preference using a diverse set of historical interaction from a source domain. The overlapping user behaviors required for the fine-tuning process are typically available but sparse, and the large language model can effectively adapt to the sparsity. After fine-tuning, the large language model-based simulator generates the simulated positive interaction for co-star user in the target domain in an offline manner, leveraging their actual interaction from the source domain. This simulated interaction serves as input for downstream recommendation model, enhance online performance while avoiding the latency issue associated with the large language model. Specifically, we analyze the historical interaction of overlapping users across the source and target domain as our training dataset. The interaction in the source domain serve as input, while their interaction in the target domain serve as output. To facilitate the training of large language model, we reformulate this interaction into an extra-folding format. And after training, the fine-tuned large language model simulator is employed to estimate the user item interaction in the target domain. To further improve the efficiency and accuracy of the large language model-based simulator, we propose two effective modules, PCP and CGI. The motivation behind PCP is that the large language model-based simulator will inference preference of an extensive number of candidate items during the simulation process, which can be very slow. And the PCP addresses by constructing a smaller personalized candidate item pool for each user using cross-domain collaborating filtering. And the CGI module refines the process by selecting high-quality target domain user interaction based on the simulator's prediction confidence, reducing noise and ensuring accurate estimation of user preference in the target domain. As such, Lasso enhanced domain transferability and simulated high-quality behaviors of co-star user for conventional recommendation modules. The experiments are conducted using the Amazon review dataset that is a very popular dataset. And following peer study, we evaluated our approach on 3 cross-domain tasks, task 1, 2, 3. For example, in task 1, the book domain serves as a source domain, while the movie domain represents the co-star target domain. And for the baseline, we choose 2 categories of SOTA CDR method. Direct mapping method transfers user representation through a neural mapping function, and the meta-based mapping method integrates a meta network to replace traditional mapping function, thereby enhance data efficiency. We evaluated the overall performance. The results are present in Table 2 and Figure 3. And as shown in Table 2, the Lasso outperforms all baseline across 3 tasks, achieving a notable performance marking while demonstrating higher data efficiency. And to further analyze data efficiency, we evaluated the performance of each method with varying amount of training data. As shown in Figure 3, Lasso consistently achieves superior performance while requiring fewer overlapping users for training. And we conduct ablation study to evaluate the performance of the following variants. Lasso without AS removes the simulator and treats all candidate items constructed by the PCP module as simulating interaction, and without P replace the personalized candidate pool with randomly selected item, and Lasso without 3 removes the CGI mechanism. And we can see that each module of the Lasso has a positive effect. And then we examine how the performance of Lasso varies with different number of simulating interaction. And we can see from figure 5 that reveals that increasing the number of simulating interaction generally improve performance compared to the base model. We then explore the effectiveness of Lasso across various traditional downstream model using the simulating interaction generated by our Lasso as inputs. And as shown in table 4, Lasso consistently improves the performance of various downstream model across all 3 evaluation tests. And finally, we investigate the real-world application of Lasso within the context of the Kuaishou e-commerce platform, that is a popular e-commerce platform in China. And our analysis focus on transferring user preference from the live stream domain, which is source domain, to the task of a product recommendation, that is a target domain. Specifically, we aim to leverage user extensive live stream interaction, including clicks, viewing history, and to enhance the product recommendation accuracy. We find that Lasso effectively enhance the performance of the base model. So in conclusion, we first highlight the data efficiency challenges associated with the overlapping user in the CDR task. And for the first time, we propose the use of large language model to tackle this challenge. And secondly, we introduce Lasso, an effective framework that adapts large language model as a user simulator to estimate cross-domain user preference enhanced by the PCP and CGI to improve the efficiency and accuracy. And finally, we conduct extensive experiments on public benchmark dataset and real-world industrial dataset to evaluate the effectiveness of Lasso and provide insight into its performance. And thank you for listening. Thank you.